delivering quality education, expanding access to learning. The official TV-based instruction of Tagum City. This is Tagum City Division's DepEd TV. Tara na!
Hello, our dear learners! Today is another day for a new and digital way of learning in the world of mathematics. I am so glad to be part of your journey as you discover this new lesson through television. Airing from Tuwasan TV Eskwela, I am your teacher on air, Teacher Loislene Arpaglan from Jose Tuwasan Jr. Memorial National High School in the service of DepEd Tagum City. Aiming to continue education amidst the challenges brought by the pandemic. Together, we will master our competencies while staying at home. So, what are we waiting for? Let's start the lesson. Our lesson for today is all about combinations. Module 2 of Quarter 3. Let us learn while having fun. Indeed, expect a meaningful learning. Learn plus fun equals meaningful learning. After going through this module, you're expected to illustrate the combination of objects, differentiate permutations from combination of n objects taking r at a time, calculate the combination of n objects taking r at a time, and solve problems involving combinations. Before we delve deeper to our lesson, let us try answering the pretest, which will measure your previous knowledge about the topic. Please answer what is asked. You'll be given 5 seconds to answer each problem. And when you hear the sound, then time is up. Are you ready? Please make sure that you have with you your Quarter 3, Module 2, Self-Learning Module, your pen and paper. Okay? Let's begin. Number 1. Which of the following situations illustrates combination? Letter A. Arranging books in a shelf. B. Entering the PIN of ATM card. C. Winning in a contest. Or letter D. Picking 3 marbles out of 10 marbles from a box. Your time starts now. The answer is letter D. Picking 3 marbles out of 10 marbles from a box. Number 2. Which of the following situations does not illustrate combination? Letter A. Choosing 5 questions to answer out of 10. B. Matching shirts and pants. C. Forming a committee of brigada volunteers. Or letter D. Forming plate numbers of vehicles. Your time starts now. The answer is letter D. Forming plate numbers of vehicles. Number 3. Calculate the combination of 5 taken 3 at a time. Letter A. 5. B. 10. C. 15. Or letter D. 20. Your time starts now. The answer is letter B, 10. Number 4. In how many ways can a committee consisting of 3 members be formed from 6 people? Letter A, 12. B, 15. C, 18. Or letter D, 20. Your time starts now. The answer is letter D, 20. Number 5. If there are 7 teams in a basketball tournament and each team must play every other team in the eliminations, how many elimination games will there be? Letter A, 7. B, 14. C, 21. Or letter D, 28. Your time starts now. The answer is letter C, 21. How's your score? Congratulations for performing well. It's time to move forward. This time, study the task below and identify which situations are order or arrangement important and which are not. Number 1. Assigning seats to students. 2. Entering the pin of ATM card. 3. Picking 2 balls out of 5 balls from a box. 4. Matching blouses and skirts. 5. Forming plate numbers of vehicles. And 6. Forming a committee of 3 members from 10 people. In which activities are order or arrangement important and which are not? Situations 1, 2, and 5 are activities in which order or arrangements are important. These are 1. Assigning seats to students. 2. Entering the pin of ATM card. And 5. Forming plate numbers of vehicles. Try to recall your previous lesson on Module 1. Situations 1, 2, and 5 illustrate permutations which refer to the different possible arrangements of a set of objects. How about situations 3, 4, and 6? These are activities in which order or arrangements are not necessary, and these 3 situations, namely, picking 2 balls out of 5 balls from a box, matching blouses and skirts, and forming a committee of 3 members from 10 people are examples of combinations. So, what is a combination? Combination is the number of ways of selecting from a set when the order is not important. The number of combinations of n different objects taken r at a time is denoted and defined as combination of n taken r at a time is equal to n factorial over r factorial times the quantity of n minus r factorial, where r is greater than or equal to 0 and less than or equal to n. Let's have these illustrative examples. Example number 1. Calculate the combination of 4 taken 3 at a time. Using the formula of combination, let us substitute the value of n, which is 4, and r is 3. This becomes combination of 4 taken 3 at a time equals 4 factorial over 3 factorial times the quantity of 4 minus 3 factorial. Then, perform the operation inside the parentheses. That is, 4 minus 3 equals 1. This becomes 4 factorial over 3 factorial times 1 factorial. After that, find the factorials of 4, 3, and 1. How to find the factorial of 4? Just simply multiply all the integers together from 4 down to 1. Same thing with 3. Hence, 4 factorial is equal to 4 times 3 times 2 times 1. 3 factorial is 3 times 2 times 1, and 1 factorial is 1. Next, perform the division operation. For easy solving, you may cancel common factors or common numbers found both in the numerator and in the denominator. The common factors are 3, 2, and 1. Therefore, the combination of 4 taken 3 at a time is 4. Now, it's your turn to answer this. Find the combination of 6 taken 4 at a time. I'll give you 10 seconds to answer. Combination of 6 taken 4 at a time is 6 factorial over 4 factorial times the quantity of 6 minus 4 factorial. Then, subtract 6 and 4. This becomes 2. That is 6 factorial over 4 factorial times 2 factorial. Next, find the factorial of 6, 4, and 2. This becomes 6 times 5 times 4 times 3 times 2 times 1. 4 factorial is 4 times 3 times 2 times 1, and 2 factorial is 2 times 1. After that, perform the division operation. For easy solving, let us cancel common factors found both in the numerator and in the denominator. The common factors are 4, 3, 2, and 1. Afterward, you multiply 6 and 5, and this becomes 30. And 2 times 1 equals 2. Finally, divide 30 by 2. Therefore, the combination of 6 taken 4 at a time is 15. Is your answer correct? Wow! Very good! Now, how can the concept of combinations help in solving real-life problems or in formulating conclusions and making wise decisions? You will find out in the next activity. Study this illustrated example on how to solve problems involving combinations. In how many ways can a teacher choose 3 math quizzers from among the 5 learners? Let's keep thinking about different ways can a teacher choose 3 math quizzers from among 5 learners. If we let Anna, Bea, Kathy, Dana, and Em are the 5 learners. By listing the different possibilities are Anna, Bea, and Kathy. Anna, Bea, and Dana. Anna, Bea, and Em. Anna, Kathy, and Dana. Anna, Kathy, and Em. Anna, Dana, and Em. Bea, Kathy, and Dana. Bea, Kathy, and Em. Bea, Dana, and M. Kathy, Dana, and M. So, how many combinations are there? There are 10 possible ways. How to find the number of possible ways using the formula of combination, which is combination of n taken r at a time equals n factorial over r factorial times the quantity of n minus r factorial, where n is equal to 5 and r equals 3. So, combination of 5 learners taken 3 at a time is 5 factorial over 3 factorial times the quantity of 5 minus 3 factorial. Then, subtract 5 and 3, and this becomes 2. That is 5 factorial over 3 factorial times 2 factorial. Next, find the factorial of 5, 3, and 2. This becomes 5 times 4 times 3 times 2 times 1. 3 factorial is 3 times 2 times 1, and 2 factorial is 2 times 1. After that, perform the division operation. For easy solving, let us cancel common factors found both in the numerator and in the denominator. The common factors are 3, 2, and 1. Afterward, you multiply 5 and 4. This becomes 20. And 2 times 1 equals 2. Finally, divide 20 by 2. So the combination of 5 learners taken 3 at a time is 10. Therefore, there are 10 possible ways can a teacher chooses 3 math quizzers from among the 5 learners.
Now, it's your turn to answer this one.
City Sports Development Department holds a volleyball tournament and there are 6 participating teams. If each team must play every other team in the eliminations, how many elimination games will there be? I will give you 15 seconds to do it. Time is up! Is your answer correct? Let's check it out. Take note, there are 6 participating teams and we let A, B, C, D, E, and F are the 6 teams. Among the 6 teams, 2 teams will be played at a time. Thus, by listing, we come up with following combinations: AB, AC, AD, AE, AF, BC, BD, BE, BF, CD, CE, CF, DE, DF, and EF. How many eliminations games will there be? So, if we're going to count all the combinations, there are 15 eliminations games. How to solve the problem using the combination formula? What do you think are the values of N and R? Since there are 6 participating teams, therefore, the value of N is 6. How about the value of R? Take note that a volleyball game can only be played between 2 teams at a time. Therefore, the value of R is 2. That is combination of 6 teams taken 2 at a time is equal to 6 factorial over 2 factorial times the quantity of 6 minus 2 factorial. Then, subtract 6 and 2. This becomes 4. That is 6 factorial over 2 factorial times 4 factorial. Next, find the factorial of 6, 2, and 4. This becomes 6 times 5 times 4 times 3 times 2 times 1. 2 factorial is 2 times 1, and 4 factorial is 4 times 3 times 2 times 1. After that, perform the division operation. For easy solving, let us cancel common factors found both in the numerator and in the denominator. The common factors are 4, 3, 2, and 1. Afterward, you multiply 6 and 5. This becomes 30, and 2 times 1 equals 2. Finally, divide 30 by 2. So the combination of 16s taken 2 at a time is 15. Therefore, there are 15 elimination games that will be played given the 6 participating teams.
How was the activity? Were you able to perform the test successfully? I am sure you did a great job. Congratulations! Let us remember that the number of combinations of n different objects taken r at a time is denoted and defined as combination of n taken r at a time is equal to n factorial over r factorial times the quantity of n minus r factorial, where r is greater than or equal to 0 and less than or equal to n.
Now that you have understood how to calculate the combination of n objects taken r at a time, solve problems involving combinations. So, this time, let us check your understanding. Let us assess your learning by answering this problem. You will be given time limit for each problem. Let's begin. Problem number 1. Which of the following situations illustrates combination? A. Opening a combination lock. B. Assigning seats to learners. C. Choosing 3 household chores to do. Or letter D. Determining the top 3 winners in math quiz speed. This will be answered for 5 seconds. Your time starts now. Time's up! The answer is letter C. Choosing 3 household chores to do. Problem number 2. Which of the following situations does not illustrate combination? Letter A. Listing the elements of subsets of a given set. B. 3 students posing 4 pictures. C. Selecting 4 dama players out of 8 students. Or letter D. Forming a committee of 3 frontliners from 10 health workers. This question will be answered for 5 seconds. Your time starts now. Time up! The answer is letter B. 3 students posing 4 pictures. Problem number 3. Calculate the combination of 7 taken 4 at a time. Letter A. 28. B. 35. C. 42. Or letter D. 49. Answer this problem for 10 seconds. Your time starts now. Letter B, 35. Problem number 4. Barangay Maasahan has 9 available health workers. A group of frontliners consisting of 4 persons has to be formed. In how many ways can the group be formed? Letter A, 126. B, 130. C, 136. Or letter D, 140. This will be answered for 15 seconds. Your time starts now. Time's up! The answer is letter A, 126. Problem number 5. If there are 5 teams in a basketball tournament during the school intramural day, and each team must play every other team in the elimination round, how many elimination games will there be? A, 5. B, 7. C, 9. Or letter D, 10. Answer this for 15 seconds. Time starts now. Time's up. The answer is letter D, 10.
How's your score? Wow! Very good, students! Congratulations! You deserve a round of applause for demonstrating skills in solving problems involving combinations. I hope you enjoyed our discussion today. Let's keep learning math with fun and excitement. As a point of reflection, let me borrow Brian Herbert's line. The capacity to learn is a gift. The ability to learn is a skill. The willingness to learn is a choice. And that ends our lesson for today. This has been your teacher on air, Teacher Loislene R. Padlan. See you in the next episode, only here at Swasan TV Eskwela. Bye!